Welcome back, students. Today we're going to be talking about modeling with linear functions. We're going to see how the linear equation can apply to real-world situations and how understanding of the equations and its components can help us to interpret these equations in context of the real world and vice versa. Okay. Now, let's start out with the different ways that we can arrive at the equation of a line. My personal favorite form is the y equals mx plus b form. This is called slope-intercept form. You are going to use this equation when you are given the slope and the y-intercept. So if you're given m and you're given b, go ahead and plug those into that equation and you know your equation. Sometimes we don't get that information, and so we need to use point slope form. Point slope form you will use when you are given the slope and a point to use. Okay, and then we can use this equation and we can solve it for y to determine the equation of our line. Now, if you are only given points to use, what they're recommending here is you can use the slope formula, which is m is equal to y2 minus y1 over x2 minus x1. Essentially, this is rise over run. How much did the y's change? In other words, how much did they go up? Over how much did x change, which is the run. Okay. And you can use that to find, and then after you know the slope, well, now you know slope and a point, you can use point slope form. All right, let's get into actually applying this knowledge. So we've got a graph here over at the right that shows the distance of asteroid 2012 DA14 and how far it travels in X number of seconds. Write an equation of the line and interpret the slope. The asteroid came within 17,200 miles of Earth in February 2013. About how long does it take the asteroid to travel that distance? Okay, so let's see what information we have here. Well, we have 1 point. They didn't actually tell us the slope, but we could use this graph in order to find the slope pretty easily, because after 0 seconds, it moved 0 feet. This is another point that we can use. So I'm going to start out by identifying the slope. So my slope is going to be the change in y over the change in x. So 24 fifths, which would then be, let's see, 4.8. All right. So now we know our slope. We can now use this with the point slope form to find the equation. Now, I could use either of these points. I'm going to use this point because zeros are wonderfully easy numbers to work with. So we're using the point 0, 0, so y minus y1, the y in that point was a 0, is equal to m, which we had the 4.8, times by x minus x1, well, our x was a 0 in that point, and now we can simplify. All right, so I have my equation that models it. So now we want to figure out how long does it take that asteroid to travel that distance. Okay, so our distance is our y value. So I want to figure out how long it takes to go this distance. So I'm changing y to 17,200, and we can solve for x. I'm going to divide both sides by a 4.8, and that'll give me, that's a 1. 1x is equal to, and we're going to round this off. So I'll make this an approximate 3,583. All right, so it takes it about 3,583 seconds for it to travel 17,200 miles. Okay. So we've now used our equations. We've found some interpretations. We could then divide that by 60 to figure out how many minutes it is. But because it was that close to Earth, that's really not a long time that it would take it if it was on a collision course for it to have hit the Earth. Something to think about. All right, let's look at another one. 2 prom venues charge a rental fee plus a fee per student. The table shows the total cost for different numbers of students at Lakeside Inn. The total cost y in dollars for X students at Sunnyview Resort is represented by the equation. So we have the table for Lakeside, and for Sunview, we have this equation. Which venue charges less per student? Then after we answer that question, how many students must attend for the total cost to be the same? Okay, so it's great that we've got this equation for Sunview. So something I can say about Sunview, because of its equation, y is equal to 10x plus 600, since x is students, then I know the cost per student must be 10. Every time we have one more student, we add 10 more dollars, 10 more to the charge. So that's what our slope is saying, 10 per $10 per student. So the equation gave it to me right off the bat. Now, for Lakeside, it's not quite as clear. So let's go ahead and get that equation from that table. Since we've just got a series of what are essentially points, x, y, x, y, we can go ahead and use slope. So I'm going to do my change in y all over, my change in x, which is going to be 300 over 25, which is then going to give us 12. All right, and now let's go ahead and find the equation to this. So I'm going to use these first points and use point slope form. So y minus 1500 must be equal to the slope 12 times x minus the x value, which was 100. Okay, and then let's go ahead and get that to the other side. So we'll have 12x minus 1,200 minus 1,000, plus 1,500, added it to both sides. We get 12x is equal to, that should be, 12x plus 300. All right, so we can see that this one is going to be $12 per student. For each additional student, we're going to charge another 12. All right, so that answers the first question. $10 per student and $12 per student. Now we want to know how many students must attend for the total cost to be the same. All right, so what I want to know is, when is Sunview exactly the same as Lakeside? There exists a pretty easy way for us to do this. We can just set the equations equal to each other, because I want to know when they would be, when they'd cost the same. So I'm going to have my 10x plus 600, and that's going to be equal to 12x plus 300. We got our variable on both sides, so I'm going to minus the 10x from both sides. So now that's a 0, and we just have 600 is equal to 2x plus 300. Let's get the constants to the other side by subtracting. Let's see, I'm going to go ahead and draw that. 300 from both sides. Then we'll have 300 is equal to 2x. All right, so 2 students divide by 2. So they will cost the same at exactly 150 students. So 150 students to cost the same amount. And now we could put, if we wanted to figure out what that amount would be, we could put 150 into either of those equations. Both should give us the exact same answer because we set them equal to each other. But we could figure out how much that charge would be. All right, I hope this helps. Good luck on your practice.